Okay. If you ever can't find the video or the worked out homework after it's been turned in, please email me. Sometimes I just forget to pop them in there for you. So some of you are really good about emailing. Yesterday we checked our calculators, so hopefully they're in the correct mode. If you borrow one of mine during an actual quiz or test, I will not help you switch the modes. That's on you. That's part of what's being assessed. All right, here we go. Your triangle does not have to look exactly like mine. You could put 40 down here, or you could put the 40 degrees up here. What matters is that the hypotenuse is the hypotenuse, and the opposite has to be opposite of the 40. So I'm going to choose to put 40 degrees here. The hypotenuse is only in one spot, and then my x is across from it. Like I mentioned yesterday, I strongly recommend at the tippy top of each page of notes or homework, you write out SOHCAHTOA, because that's going to help you. So this is the sign. I have the sign of 40 degrees equals x over 8. I personally like to create a proportion, and then I'm just going to cross multiply. That's 8 times the sign of 40 equals x. It does not matter to me how many decimals you go, 1 or 2, unless I state otherwise, so I called x 5.1. All right, that's a quick recap from yesterday. Any questions on that one? Yeah, yeah.
Most of we moved in yesterday, there was the opposite of it. We had switched the signs.
What do you mean switch the signs? Do you mean the reciprocals, like cosecant?
Yeah.
Okay, those are not on the skills check today. Like I mentioned at the beginning of class, I said it's just the SOHCAHTOA and the special right triangles. All right. Now we're going to get into the new stuff. However, when I asked the other class period, they said you did do angle of elevation and angle of depression in geometry. So this will just be a refresher then. I'll teach it like you haven't seen it. But here's what I want you to do. The terms angle of elevation and angle of depression are often used in word problems, especially those involving people as they look up or look down. So when I have an angle of elevation, it's the angle up from a horizontal line. Change colors, and an angle of depression is the angle down from a horizontal line. Now I've taught this so many years, but when we do angle of depression, I have students who don't take it from the horizontal. They do it from the vertical. And I'm like, both of these are from a horizontal line. So let me explain with a diagram. This is a horizontal line, technically a ray, but you get the gist. Well, I guess I'm doing an angle of depression first. Okay. So an angle of depression is looking down from the horizontal line. It is not over here, okay? If I drew a building, it's not this angle. It has to be coming, so this is an angle of depression. So it's always from a horizontal line. Then I meant to really do this one first, but that's okay. We'll work with it. Here's my horizontal ray. I'm going to call it a horizontal line. If I'm looking up, that's an angle of elevation. So remind yourself, no matter whether it's angle of elevation or angle of depression, it's the angle formed from from the horizontal line, whether you're looking up or looking down from the horizontal line. All right, let's look at example 2. We'll look at a problem. Ryan's kite is flying above a field at the end of 65 meters of string. If the angle of elevation to the kite measures 70 degrees and Brian is holding the kite 1.2 meters off the ground, how high above the ground is the kite flying? So one of the hardest parts about this is getting an accurate picture. So I have an angle of elevation. So what I'm going to start with my sketch is I'm going to draw a horizontal line. An angle of elevation is looking up. So this is Brian. And Brian is holding this 1.2 meters off the ground. Here's the kite. And it says Brian's kite is flying above a field at the end of a 65-meter string. Where am I going to put the 65? On the hypotenuse, because it's the string, right? So here's a decent looking sketch. Now, I'm going to find x first. Okay, I'm going to find x, but x is not the answer to the question. But x is going to help me find the answer to the question. So I look, I did write it. There's my SOHCAHTOA. So in the triangle, so the 1.2 is not in the triangle. Do you understand that? It's not in there. But in the triangle, which trig function is this? Sine, because it's going to be the sine of 70 equals x over 65. Well, it's a good thing we reviewed example 1, because now this is a very similar setup. So use your calculators and solve this. And again, x is not the answer to the question, but it's going to help us get to the answer. So I got 65 times the sine of 70 equals x. So I got x was about 61.1. Did you get that? Okay, now that's not my answer. I'm going to reread the problem. It says, how high above the ground is the kite flying? What would we need to do to figure that out? Yeah, Elena? Yeah, there you go. So that's what, 62.3. And I need to tell you something. In word problems, I'm going to be a stickler for your units. Okay, if you're given units, then we need to make sure we're indicating the units to make it crystal clear. All right, questions on this one? All right, it's not too bad. It's really not too bad. All right, let's look at example 3. An airplane pilot sights a life raft at a 26-degree angle of depression. If I have an angle of depression, what do I need to remember? Okay, I'm looking down, but what else? From a horizontal line. So what I strongly recommend is when you see angle of depression or angle of elevation, draw a horizontal line. Angle of depression is going to look down. So that's this piece right here. Is from the horizontal line. I'm looking down. This is the pilot. Here's the raft. And it says the airplane's altitude is 3 kilometers. From geometry, what does the word altitude mean? Say it again. It's the height, right? And it's technically the perpendicular height. Okay? Altitude means perpendicular height. So here's what's interesting about triangles. We can use some geometry here, and the altitude of the airplane is 3 kilometers. Well, this creates a rectangle. And what I know about rectangles is their parallel sides are congruent. So I can then create 3 on the inside of my triangle, even though it was directly underneath the airplane, okay? One other thing I'm going to bring back from geometry is, remember you learned about alternate interior angles are congruent. So we're going to use that piece. So if this angle is 26, this one's 26. And now you don't technically have to use that one, but guess what? You could then use this triangle or that triangle, either, because they are the same. They're congruent. So it says, what is the airplane's horizontal distance? We're going to call that D. So I can actually write 2 different equations that will work for me. I could say from the top one, the tangent of 26 degrees is 3 over D, and I can solve that. The other option is I could use this triangle down here. Oh, no, that would give me the same thing. Let me do this. What about this idea? If I take 90 divided by 26, isn't this angle down here 64? I could actually write this trig equation. If you don't like the variable in the bottom, in a right triangle, you could find the missing angle and put the D on the top. Does that make sense? Either works then, whichever way works for you. Again, I'm going to make a proportion, and this would be D times the tangent 26 degrees is 3. Divide by the tangent 26 degrees. And D is about, I have 6.15 kilometers. Again, round 1 or 2 decimals. All right, let's look at the last example. Example 4. 2 hikers leave their campsite. Emily walks east, 2.85 kilometers, and Savannah walks south, 6.03 kilometers. Create a sketch. So let's do that. So here's Emily at 2.85. Here's Savannah is 6.03. Here's a sketch. So east is to the right, north is up, west is left, and south is down. In case you never learned, what is it? Never eat soggy waffles or something like that. All right, after Savannah gets to her destination, she looks directly towards Emily's destination. So between Savannah and Emily, we're going to close the triangle, and it says, what is the measure of the angle between the path that Savannah wrote, so that was directly south, and her line of sight to Emily? So I want this angle here, and I'm going to use theta. You could use x, you can use whatever letter you want. In trigonometry, it is traditional to use theta. That's the most common variable for an angle. All right, what is the measure of the angle between the path Savannah walked and her sight, theta? So let's look at the picture a moment, and what trig function would I use? Tangent, because I have opposite of theta and the adjacent. So I'm going to write tangent theta equals 2.85 over 6.03. So now we're going to tie this together with what we did yesterday. I need to undo the tangent function. What was it we used that would undo it, Jared? Inverse. So I'm going to take the inverse tangent of both sides. Now you are allowed to skip that step if you want and just write theta equals the inverse of 2.85 over 6.03. Because inverse tangent and tangent knock each other out. Okay, they're inverses of each other. So use on the graphing calculator, when you press trig, there's an inverse button on the bottom row on the TI Nspire. So I got 25.3 degrees. Make sure when you're finding an angle and it's in degrees, you include the degree symbol. Something you don't know that's coming is we're going to find out about another unit of measure for an angle called a radian. Just like you have feet and you have meters, those are 2 units of length, but they're different systems, okay, metric system and the US system. Well, we have degrees and we have radians. So if you don't put a degree symbol, that is assumed a radian. So it's imperative you put the degree symbol. So we're going to practice it now. All right, now it says, how far apart are Emily and Savannah? So that is the hypotenuse. Now, I can think of at least 4 ways to solve it from here. And you can do it whichever method you want. But guess what I'm going to do? If I know 2 of the 3 sides of a right triangle, I know a squared plus b squared equals c squared. And I can do Pythagorean theorem. But you can also do sine, cosine, and find x that way, and that's okay too. Include your units